There are lots of proofs for Pythagoras' theorem. I like this one because it's nice and simple. Now what I've drawn here is two big squares that are exactly the same size and shape. How can I be sure? Well, if I look at the length of the side on my squares, I've got a length of A plus B. So whatever A and B are, all four sides in both of my squares are A plus B long. Okay, what else is happening here? Well, I've drawn another square inside this square, but just tilted, okay? And what that's given me is a bunch of leftover spaces, these triangles. Now, if I compare the triangles, I can see they're all the same as each other. They all have a short side that is A long, and they have a long side that is length B. And they've all got right angles in the corners because if this is by definition a square, then they are also by definition right-angled triangles. And they all have a long hypotenuse of C. So we can see all those four triangles are the same. Now what happens when you take two identical triangles? Well, you can take, say, this one and this one, fold this one down. You can always put them together to make a rectangle, can't you? So that's what's happened here. If we take two triangles and place them together, we can make this rectangle here, which is A long and B wide. And I've taken the other two triangles and placed them down here, and they will come together also to make a rectangle that's B long and A wide, or vice versa, however you look at it. So if we've got four identical triangles in this one and in this picture, then we could pretty much just discount them and say, well, without the triangles, what's left must be the same size. And how do we measure size? Well, we look at area. Now what's left on this side is a square, and we know how to find the area of a square, side times side. So we have C times C, and we can be sure that the area of this shape here is C squared. Over here, the white bits that are left over are also squares. We've got a little square up here, which is A times A, so it has an area of A squared. And down here, we've got a bigger square, which is B times B, B squared. So this is a really nice simple proof that shows us that A squared plus B squared equals C squared. Now this only works if you are really clear about the fact that C is the long side of a right angle triangle, and we have a special name for that, don't we? We call that the hypotenuse of a right angle triangle. If it's not right angled, then this doesn't work. So that statement there really just qualifies it and makes it true. Another nice simple proof of Pythagoras' theorem involves looking at areas in a different way. If you take a right angled triangle, label it ABC, where of course C is always the hypotenuse, which is directly opposite the right angle. Then if you then take this side length C and build a square out here, where all the lengths of that square are C, you can see the area of this part is C squared. Similarly, if you take this length A and build a square out here, where all the side lengths are A, you'll have a square with area of A squared. And down here, do the same with side length B, and you will have B squared. Now, you've got an activity to do where you get to cut and paste here. If you cut out these two squares in a certain way, you should be able to make them fit perfectly onto the big square. So you can go ahead and print out your cut and paste activity now and see if you can make them fit.